Good evening, guys. What we'll do tonight is something a little bit different. There we go. Right, I had a beep on beep off that I thought, well, it's about time we got to see the answers to the problem, or this particular one anyway. And it was a real old rabbit hole, to say the least. It started off in a 12 volt, and that was just the, let's just get some of this just out of the way for a second. That was one of the FETs that had gone short, so sorted that out. Got 12 volt back on this board. It's now pretty empty, as you can see. And I found that the IO memory voltage, the 1.1 voltage rail was deceased, but everything else was fine. And in looking into it, found, which is looking to start to be a common problem, is the two FETs on the RAM power supply, which is a decap system. I'll try and get this over here and show you a bit better. I'll just drag the old scopey over and just to show a little bit. I'll go down a bit, see if that'll come in. That should be okay, I think. Okay, let's have a look. What one do I want? Yeah, it's a little bit iffy. That'll have to do. I'm afraid the overhead lighting is playing havoc. I've got some filters on order to hopefully resolve the issue. But the two FETs up here, that's the high side, that's the low side. And the gate drive for these comes off this chip, pin 11 and 14. Now when one of these goes, if it goes short between gate and say the high side, that sticks 12 volt straight down to this device here. The device will shut down, that's not a problem, but when the low side goes down, it pulls the output down on the drive in on pin 11 to ground. Now you have a 5 volt fin coming in on pin 12 here, and you can see I've got a little blob of solder there. When that happens, 9 times out of 10, pin 12 here is a tiny little bit of print, goes to a tiny little bit of the board there. I don't know if I can get this any closer without it going all up the hell. Hang on. Yeah, just about make it out. So get a little bit closer into that. Okay, I think we're just about there. Let me just have a look myself. Get it in perspective a bit. But yeah, actually there's still a hole in the track on this one. If I can get this focused a bit better for you. Right, there you go. Now if you look, pin 12, okay, well pin 1 is where the board is here. So you've got 5, 10, 11, 12, and as you can see there's a hole right through the print here. Now that's the 5 volt in, which feeds the drivers, which then drive out on pins, I think it's 11, 14, which drive the gates for the FETs. That is what it blows that bit of print out. This will cause beep on beep off, but the thing is, it's very hard to spot. Because it blows, but it doesn't always blow the coating off the top. So it's always a good point to check on this one for that. And last week I found 2 beep on beep offs were caused by that particular bit of print. Now the other thing can happen, of course, it does take the chip out. Now the problem I've had with this board was after even going through that, I thought, okay, let's get a bit radical here. So we started pulling off FETs and heavens knows what else. As you can see, it's pretty naked at the moment. Took it down to some big workshop on the reballer, and just warmed it up and just slowly took bit off by bit until we found where the short was. And I was convinced that it was in on the memory, because I was only getting 0.7 ohm and that was on a 4-wire resistance bridge, so it was definitely that low. Normally read 58 to 60 ohm across there on the average good ones, you know, when they're not short. But anyway, cut this down a bit short. I pulled everything off, including South Bridge, and all I ended up with was CPU, really. So, well, I thought, oh, there you go. So I hoisted that off, and lo and behold, the short disappeared. Now, on hunting around, I have found that there are several pins that do tally up from the CPU to the 1.1 volt rail on the output from here, this coil. There's your output there. From there, I'm going to have to try and map this out a bit better if I can, and then well, try and find. I'm wondering whether there's a way we can isolate the even if it's a bit of track, we could just cut to prove a point, but that'll come in time. I've virtually nearly got the circuit of this all drawn out here, and all the information about it all. There's some interesting items if you're into. I'm a bit of a geek when it comes to test gear, and I don't think my oscilloscope ever gets switched off. And you can look at the waveforms that come out to the FETs, and you've got various modes this chip runs in. It's called decap, and the various decap 1, decap 2, I think it's decap 3, decap plus. This is basically like a switch mode driver, and it's got an awful lot of technology in such a small chip. I don't want to go too deep into it, but it's designed to give a very, very, very accurate supply with very low ripple, because as you can imagine, any ripple on the memory is going to give you memory plague. I suggest if you really want to find out, there's if you go to the website, I might paste a link for it, because there's a great video that tells you all about how this thing works, and it's quite interesting. Anyway, I digress. So while I was at it, I've had the South Bridge off, and also the EMMC, the flash memory for the South Bridge, and I thought we'd read it. Now, as I say, I've been reading the PS4s. Now that's quite easy and straightforward. I use a reader with a, hang on, that's the reader for the EMMC. Let me just jag this other bit kit over. I'm going to have to unplug it for the moment. There we go. And that's the reader. So, I mean, there's all sorts of ways you can do it. This is a quad. What do you call it? Oh, I'm terrible. As soon as I start recording, I forget things. FPI. So there's all sorts of ways. There's I think the aardvark was the original one of embedding, but it doesn't read quad. It'll only read single channel. So basically, it means it's very slow in reading. Whereas this is quad SPI, so that will read the chip very quickly because it's ferrule size. So that basically plugs into this, and I can read the chip, and we can do all sorts of things, which I'll do that another day. What I want to do is to try and read the memory of the you know what I mean. Right. So what we've got a socket which takes an EMMC or a NAND, whatever, as long as it's under 35 pin, under 3 pin, sorry, BGA, it'll read it, unless the chip is actually faulty, which unfortunately I've got a horrible sneaky suspicion the one I've removed could be. Now there's the chip. Now I think we could go back under the Microscope for a moment. Where do I want Microscope? Is that it? No, it's not the one. That one? No, that's not the one. Well, why can't I find it? It's got to be that one. There's that one. Okay. Right, here we go. Now it's fairly clean, but I got a feeling that because it's not been reballed, I think the pads are not quite, there's not enough extension on the pads to touch the pins on the reader. Inside the reader you've got sprung loaded little pegs. I'll show you in here. Oh look, we're out of focus. Whoopie-doo. Can you see that? No problem. Let's wind it up a bit. There you go. There's the little pegs. Now the 8 data lines over that far side on the right. So what we need to do, I think, is we're just going to have to reball the IC. Let's just pop that up there a bit. Hang on. There we go. It's a job to see. My camera's crap, I'm sorry. I am going to get a new camera, but I'm still having problems with my broadband, so there's no point in me going out in 4K at the moment. I can just about scrape 1080. Anyway, I'll pop that away. Now we've got to reball this little baby here. So we'll have a look at that. Now, where are we? Yeah, how's that look on there? It's the old problem, reflected light, and the auto settings on these cameras is vulnerable. It's about as best I'm going to get. Okay, so I'm going to have to refocus it anyway, because I'm going to have to get the my little gadget out. Alright, here's one. What we'll do, we'll go for the other camera for a second. And I'll play with this, I'll bring that one over in a minute. Right, one reballing gadget. Let's see if we got the right size. Hang on that. I think we're going to need to put the shim underneath that. Yeah, what's the shim? Right, so let's have a look, see what we got. Okay, I've also got a load of the DDR2 or 3 off the S-Box. I think we've got now this is the weird one. This DDR3 memory here has actually got a little bar in the centre, is actually proud of the chip, and what it does, it acts as extra heatsink, so unless these are reballed, they won't contact. So I'll try and show you this if I can. Let me just find something to hold it with. If you know what stack my fingers on this microscope, that's scary. They look like something like an alien. Come back a bit. It's on top. You can just, if I wind this up a bit. There you go. Can you just see it? That bump in the centre. You see what it is there. And you can see from that side, you can see it just protrudes. So that means the whatever you use to reball has got to be the thingy bob with a slot in the centre. I don't honestly think I have one in here. I have got one. Yes, I have. Ah, there it is there. So there's the one with the slot in the centre. It's just got a little bit cut out. So I might leave that out because I possibly will reball. Oh, I won't. I'll do them later. Right, here's a couple of shims. Now, what I've got to do is find the BJ. I've done the BJ. Oh, have I got them on this one maybe? Oh, right, yeah, I see what I've done. I'm a clown, I've got them mixed up. Forgive me. That's the old age for you. But with that and shaky hand syndrome, I do quite well. Although that's not been so bad. Unfortunately, some of the tablets I have to take have been causing me some issues, and one of them was shaky hands, which is not the best of things. Excuse me a minute, I'm going to have a closer look at this. EMMCs. Let's have a look. Now, that is. Let's have a look. I think there's some shims in here as well. Yeah, there. Right, oh, we want 153. Now, there's various types. That's 153, 254, 221, 186, 169. Okay, what's this one? I think that's the some shims. What we got in here as well? Oh, that's the 162. Okay, right. Let's see what we have here. These are great little kits. They, as I say, they're not particularly cheap. They're magnetic based. I think there's several of them now actually. I haven't seen these two little shims before. And I've got to be honest, I haven't used this to rebore BGAs. I've only just got this one. I've been using my own little concoction, which does work quite well. Oh, I've got a spreader, I see. Right, so what we've got to do is establish which groove this sits in. Now, depending on which shim you fit in, by the looks of it, as to which grooves are available. Just going to have a nosy under here to see which way this slots in. It would seem to be, oh, I thought it would be there. It is there. Alright, okay. So it does slip that way, but that's way below the surface by crikey, good middle and a bit. So we've got, let's see what shims we've got. That's 0.15. Can you see my, oh no, I'm doing it again, look. Let me come out a little bit further. Okay. Alright, so we've got shims, that's 0.10, 0.15 there. Then we've got these which lift the actual stencil up. I suppose a lot of this is down to how much or how big you need the balls. Alright, we'll hop this out the hole for a sec. And we'll hop in a couple of shims. There's one. Oh, hang on, I've got them the wrong way. Idiot. Okay. Now let's have a look. Well, that's actually quite flat. It's fraction below, but you would need something. You would need some space, a tiny little space for the ball. So I'll see which way around this goes. There's the key. It's on the inside that way. Okay. Yeah, it does still feel far too high off the chip. Excuse me a moment again. And we have a closer look at this. I'm not convinced that actually is right in. No, it's not. It's not fitting in that. It's not, the actual metal isn't fitting in the in there very well. Yeah, it doesn't quite. Okay. Let's just whip this out for a second. It just makes it a little bit easier to manage. Okay, so have a look what we got now. Now she's gone in now. Just needed a little bit of persuasion. Yeah, still not convinced that's right. It looks like there's too big a gap between the actual stencil and the chip. There certainly is no room for any other templates in there. I certainly won't be wanting those because I would make it even higher up. So why is that? Appears to be too high. I think we're going to have to try it and see. I'm just going to pop. I just don't think that's quite sitting down in that groove as it should be. It's sitting on it, this side here. You can see down the edges here. I think that's gone down a bit better actually. Yeah, I think that's better. Let's have a look under the scope, we'll see. Let me just drop that back in here. Pulls it right down. Right, let's have a quick nosy. Yeah, it's in there. There's one particular area. It doesn't look very nice. You can see the black areas. I'm not sure if that's light or muck. Yeah, somewhere on the pad, on the boat, on the pads. Okay, let's have that off again then. Oh, they look alright. It's got to be on the stencil one, doesn't it? I just don't want to sit on that magnet. Just turn it over a second. I want them to come out. Well, they look alright. I wonder if it just be a reflection. I suppose that's possible. You can get some really peculiar oh, I can't see it back in the right way now. Let's stick it back on there. There we go. Right, we've got the extra pin on the bottom there. So that is that way. Okay. It's easy to make mistakes doing these things, especially when you're trying to make a video or trying to do something. And I am pretty good at fucking things up, excuse my French, in front of people because I get nervous. Why, I don't know. I sing in a band, I was a DJ for many years, which never worried me. I think it's because there's nobody there to react. That looks a bit better. Okay. Get out of it. Yeah, it does look slightly off, doesn't it? It wants to go slightly up a tad, but I got no. Oh, that's it. That wasn't quite down. Okay, right. Well, what have we got on the heat? Don't want much on here for reballing. Probably. Oh crikey, 300. 310 should do it. You don't need a lot when you actually big balling a chip, because don't forget you haven't got the board to sack away all the heat. I just wonder which reballing paste to use. This one's a nice paste, but the trouble is the balls are rather large. I think they're, I can't remember what grade they are, but let's have a look and see. There's quite a lot of different ones. I got also I got unleaded bismuth, which is low melt, but it's unleaded. Problem that is though, if the chip gets over 160 degree, it dissolves the solder. Right, if you see if we can see this. Hang on. Normally you can actually see the balls when you spread it out a bit. There you go, you zoom in there. Yeah, that'd be alright for this. I don't know if you can see that or not. I might show you better. There you go. Oh, I don't know if you can see it on the screen. Hang on, let me go over to the screen and have a look. So you see it under the eyepiece. Oh, you can't see it on there, can you? Let me try a bit more light. No, it's shutting down. I think possibly need to adjust the camera, but let me see if I can't. Yeah, it's slightly out on the exposure. Alright, trust it. Take it from me, those balls are there and they are very clear, but I can't see them on the camera. I don't know if I can. Anyway, I can adjust the camera, can't I? There we go. Let's have a look. Let's just take the exposure down a little bit. No, it's probably also go up then. Gamma could go down a bit. Trouble is, it's not particularly very adjustable. Seems to be all or nothing at times. Contrast, saturation. Not really doing a lot, is it? I think about about 60, 69, 70. Yeah, I think we're just going to have to play with this as it goes. Let's just have a twiddle the focus again. The biggest problem is the latency between adjusting the focus and it actually becoming focused. Now that pace is actually on top of that other bit, so there we go. Okay, let's get a bit that way. There you go, you can see the little tiny balls there. Right, now we can have a play. Can't make a difference just moving that. Let's go down a bit. That didn't help, did it? Probably better there. Let's have a look at the saturation. No, because that's actually silver, so that's a load of rubbish. It ain't that colour, is it? Gamma is the biggest one. It can cause all sorts of grief. You can see it's actually gamma. It's like a contrast and brightness all rolled into one. I'm trying to get them dead right is an absolute bloody nightmare. We'll keep an eye on it as it goes and then have to have a quick adjustment. Right, let's go back to this thing and get this back into focus. It's not great, but it's not bad. Let's come back out a bit, hang on. As I say, the camera's moving about a fair bit on the bench. But I have to do. Right, now really I suppose I should go and get some paste out of the cupboard. Or I'll tell you what, I'll take the nozzle off this one. We'll give it a go. If it don't work, I might just have to redo it. That's no big deal, is it? Just dump a dollop of it. Oh, of course you can't push that, you have to rotate this. There we go. Dump it on the side here for the moment. Yeah, as I say, there's several types of paste, have grades. The grades are basically on the balls. I'll tell you what, that's bright as hell looking into that. Through the eyepieces, anyway. We'll give that a puff. I may need a second application. And we'll see. Right, well, we're going to go at about 300. Might have to go up a little bit actually, because there's quite a lot of metal on there, isn't there? Let's go 320. And we're at, I think, about 52% on airflow. That's fine. And I don't know what size nozzle that is. I would guess it's about 8mm. Yeah, it may not be hot enough. Not this small nozzle, let's go up a little bit. Oh, it's now gone up to, well, it's 335, 340. Yeah, that should do. Might dry out a bit. See how much it streaks. No, it's no flash yet. Right. Slightly warm, and then we'll go for it. You hear the actual stencil moving, which it shouldn't do, being magnetic. I'll hold it down just in case. There we go. That should look quite nice. Okay, right, cool. I'd say that was reasonably okay, that was. I don't think that's going to need a second coat, as they say. Second coat. Right, so there's a little bit of solder paste there, which is now finished with. Slide that off. My chip fell off. I think it messed it. Oh, you bugger. Oh, I don't know that. No, it was a bit of the solder paste went through on the holes. It's just got caught on the backing plate, and it's just rubbed it off on the chip. There we go. Clean that out there. Someone's got caught in it. Let's just put that over the way for a sec. And just refill my bit of tissue that I had. Okay. Okie dokie. Let's have a look, see. Pop that out of the way for a moment. Not very clever for some reason. I've got a feeling something may have. Oh no, I know what that is. Oh, that's fine. It's just a bit of residual muck that's come out of the paste. Using lower temperature, it tends to. The balls have a bigger build, but it does tend to leave it a little bit gunky, but shouldn't be too big a deal. A little bit of IPA. I've actually tracked myself to a miniature ultrasonic cleaner for doing, I think originally it was designed to do rings and things. Yeah, you can see some of that paste has gone wonky in there. You see it? Should just come off though, unless the actual conformal coating is actually damaged. I don't think it is. Trouble is, as I say, I'm not 100% sure whether this chip wasn't damaged on the Xbox, so let's have a closer look at that. Okay, I'll drop scope down in a second, hang on. No, it is, that's fine, it's just free. Oh, yeah. You see it there, it's just free roaming. Okay, so forget about that in there. So, and that should do. Something damage pick it up. If it's a bit dry, it should stop sticking and I should be able to brush it off. Okay, so if we get a tiny super fine brush. You have to be ever so gentle with it, but try to hold the chip at the same time. Okay. Oh, my hair's falling out. That's it, I'm bald now. That was the last one. Ow, I just stuck bloody things in my hand. I was meant to wipe it on the cuff of my jacket. Oh, I'm bleeding. Oh man, look. Bloody hell. These tweezers ain't half sharp. They're good on as well, the best. First set I've actually had. I got going for the post the other day. I ain't quite sure who sent me them. I'll just have to have a look. I've got all the paperwork to actually write back. Send back saying I'll leave for wet mine, mind you, they're like a dart. But ideal for doing anything small, because they, I will say, for a very fine tip tweezer, they have got extremely tough tips, and of course the big problem is when you use tweezers with heat, they tend to soften up a little bit, but these have been okay. So off you go. Bye. Okay, how we doing? Another couple of little bits. it's easy just to pick them out with the tweezers and try and brush them out. All it seems to happen is they just move from one place to another. Yep. And the last thing you want is a little bit one of those underneath the chip in the socket. Yeah. Smart the chip a bit. That'll be okay. I'll give that a proper clean now. Let's just clean the stencil. These are quite good. Directly heated. Again from Ali. I think these are about 40 quid with a magnet. I got 2 sets. Oh my word, that went straight into my... Let's come off the scanner. I'll come back to that. Went straight into the socket reader. No, hang on the top. And the IPA. Okay. Yeah, they're quite good. The this set is brilliant. Mark U, and then this one is just, it's again, I can't see that right, that's too small. Hang on. www.amaoe.com. They're free EMMC chips, basically things like that. Let's have a look. How's that look? Have we got that clean? Have a quick peekaboo. Yeah. Yeah, they're not bad stencils, I've got to say. But the thing with these things, if you don't keep them clean, they're useless if they get grubby or marked. Right, now, when you lot come out of this little pot, you're going back in. There we go. Right, where's the base? I think you can get different, what do you call it? These, I think you use either side. You can pop on this side if you want. If you don't want quite such a heavy magnet. Or either side. Whatever. They do. They've brought out a set of other stencils now. I think they do the Switch CPU. There's a few others. Right. Okay. Let's have a quick look at that and a clean. I think we better get the old toothbrush out. I can't find. I have to use the old ladies. She won't mind. Nobody tell Linda I'm using her toothbrush, eh? I'm not sure she'd be too happy on that. Fortunately, she has gone to work and left me on my toe to get on with my own devices, as they say. Right, see how that looks, and we'll see if it'll read. I've got a sneaky suspicion that this is possibly got more hair on it than mine got on my head. Why is it I can never find a thing? My head, now the chip, there we go. Oh, talk about hairy. I'm a bit of a long head gob, I'm afraid, and you can tell my hair is extremely grey. It's down to past my shoulders, it's down to about my elbows, I think. A long-haired job that plays rock and roll. And enjoys every minute of it. And an old age pensioner to boot, which ain't bad. Right, okay, that's looking pretty good. Let's see if this thing will go and read. Alright, I'm going to pop the scope, wipe that in there. That should go in there, there we go. Then we'll go over to the other cameras. What we got? That's about as far in as it's going to go. Okay. Well, this reader, you get different readers and different boards. This is the BGA 11.5mm across, so that'd be the 153 or 169, which it is. So I'm just looking in the headset to see where the dent is. Okay. That goes in like so. Like that. I'll close that. Oh, that's clever. I could do that again if I tried. I probably could actually. Right. Come on, you. Oh, come on, I get caught on those pins and bend them. I won't be very happy. These bloody sockets cost an absolute arm and a leg. Right, okay, shut that in before I forget. Right, now the reader's over here. Now I've just got to see if I can get a lead to reach from the PC. Probably not. Ain't long enough, is it? No, not quite. So I'll move that and that and that. Okay, what I'll do in a moment, I'll tweak the camera just to move across a bit. Just move that mouse out the way. Right, camera. Where is the camera? Now we want PTZ and we want. If we go for that one, which one's that? There we go. There's the reader. Now I want the reader software. Now can I bring that up on screen? I should be able to. UFPI. Yeah. So, right, that's the software. Now, let's see if it'll read it. No response. Great. That means that chip is not on the good bin. Query. Oh, I got hang on, where's the query? Oh, we're user clock, we're at 20 meg. Let's take that down to 15 meg just in case. Auto detect, CNC, RSDC, SDC, detect mode, SDC, query, no response. Okay. EMMC, read, unknown, no. That's strange. It did read when I first tried it, although it's settings auto. It read the I see, like it has here. It's reading. It recognises it's an EMMC 8-bit, or 8 bits are connected, but it's not responding. Let's try in single bit mode, see if we can get it to no. Right, let's think. So let's try using 1.8 and power on. Okay, so 1.8 soft on settings, user voltage, and try that. 1.8, still not happy. Okay, well, it could be power on, so that was set from the socket, so that'd be 3 point something volt, which should be okay. The spec on the chip is 1.7 to 3.3, so I would say that the chip may have sustained an injury, because that I did make a thing to get it off. It probably has killed it. Oh, well, that's a shame. Oh well, never mind. Well, let's hawk that out for the moment, and just pop over to the other camera. We'll pop that out. So I'm going to have a little look at it. Definitely a good chip. That's a bit odd. I mean, ideally, in fact, what I can do, I'll read this one for you. This is the sys chip out of a PS4. It should automatically set up on the software. Yeah. It's asking, why is the camera gone off? Oh right, it's defaulted over to the, hang on. I just can't quite get it into the camera at the moment. I'll move over here a bit. That's it. It's actually asking me which chip this one is. You know what? I can't remember the number on the chip. It's the hang on, I'll have a quick tweak and have a look. It's the crank. Right. No. That's the MX25L 25635. So ML 2563. Okay, so it's 256 ML2. Oh right, it's the last letter I need the difference of. Of course it is. Hang on. I forgot to look at the last letter. It's the last letter that matters. I think this is a G. Where's my focus gone? Right, 35 FMT10G. Pop that out of the way again. That's been a bit strange. It's not actually given me that absolute option. Let me just have a close look at this. I'm trying to read it all cockeyed. Well, I can't quite make out what it says on the end. Right, 25L 25635 FMI. Ah, there it is. Okay, right. Let's pop that out of the way for a second. We'll select that. Apply for a, that's fine, current ID. Right, so if we now go over to the screen, you can see there's the chip. If we query the chip, yep, and if I read the chip, overwrite existing file, no. So I'll have to get a new file. So we want to read this to PS4 NOR. I'll change this to 2 and then read. There we go. So that's reading the NOR file. Well, done. Simple as that. Now if I wanted to, you can edit the file, which is what we do, and then we write the file back. So what we'll do, I'll just write it back anyway, but what I shall have to do is to write back the same file. I don't really want to alter it. Open file for writing. So we'll go to, sorry you can't see this, but download UFPI. What do we want? PS4 NOR. To bin open, okay, and then write. So let's have a look. Write from file, write data to device, yeah, and there we go. So it's writing data to device. That's the NOR. Pretty quick. Now that's what should have happened with the Xbox, but unfortunately the chip is evidently not a happy chip, so that is not going to happen, is it? Right, let's just get this out of the way. Right, so I will unplug this reader. So put that over there. It's just a shame about that. It would have been interesting to see. What I shall have to do is hoist one off. Actually, if I've got another one here, actually, we could look at. Let's see if we can read it. Nintendo EMMCs. I'm just making a reader to fit them at the moment. My word, where on earth would I put them? I'm not even sure where I've put those. Oh well, not to worry. Anyway, that should have been an education video on how to read an EMMC. That didn't work purely because the chip's knackered, but I would like to show you how to read one if I can find another chip. I'm just not 100% sure where I've actually put the chips. Let me think. I know I put them in a plastic, what do you call it, not a plastic bag, anti-static case. No, not in there for definite. Right, that's all Nintendo parts. That is, it could be anything actually. What we got in here, so have a look. No, that's all semiconductors, as in discrete. Oh, what we got here? There's loads of little packets of chips. See if we got any EMMCs in here. What's that? No, proof post. No EMMCs in there. Nor there. Nor there. That means I have put them somewhere Pacific, I bet, and lost them. Now, what's we got here? Oh, there we go. That's some in there. Let's see what else we got here. There's a couple in there as well. Right. I'm just going to have to nip to the garden for a leak. I don't mean the garden really. I'll be back in a second. Okay, sorry about that guys. Oh, major calls, major calls. in my case. Yes, right, and we're still recording, yeah. Okay, let's see what we got. There's some NANs in here, or sorry, EMCs, EMMCs that I think are general. Don't know if I've got another Xbox one in here. It is the same chip, but it possibly, yeah, same chip. But different data. But that will do to see if the reader's working or whether I've actually got a fault with the reader, which is a good point actually, isn't it? Right, let's have a look at this one. Yeah, KMAG. I think the actual Xbox one is a 4. KM8G, so that's a bigger memory. So this is the same thing, it's just smaller memory, same pattern, same pin out, I believe. Can't see the detent on it, the pin. There normally is a gold marker underneath with an arrow there. I don't know if I can see any marks on the chip though. Let's have a look on this one again. See if that mark does correspond to the dot. Yeah, it does. I'll show you on the bottom of the chip. If we snip over to the gizmo, let's just find the chip somewhere around here. I won't see it. Okay, I think we need a bit of focus here, don't we? We've got to go down or up? I think we better go down. No, I think, yeah, we're getting there. Let's just lock that in place. There we go. Yep. That's the Xbox one, 8G, 1G, and this, as I say, is a, I think this is a 2, or what's this one? Move over. Oh, great. This is an AG, a KLA G2G, that's a G8G, just different size. Right, so on this one, the Xbox one, just want to determine the key. The dot is down the bottom left corner. So I rotate it, you see you've got a little gold arrow in that corner. Just there. Right up top there. So that means then, like this one, I can't see a mark on it anywhere. I'll roll it over and see, there's the little arrow. That top corner up there, so that top corner, if I put that around that way, is up there, that should be the right way to go into the Ujima what's it. So we stick that out of the way and we'll drop that in there. Okay, right, pop that in there. Okay, let's go and see if it recognised it. What do we want? We want the screenshot, don't we, that one? Aha! No response! So it looks like I got a problem with the reader. Right, well if we can see why that's not working, then we still may be able to go on to read. Let's have a look. So, what are you? It's recognised it's 8-bit. EMMC. Let's go to auto detect. Auto clock. 8-bit mode. And query. No response. Right, okay, well that says to me that either my reader has gone tits up, or I'm unlucky enough to have some bad memory, but I'm pretty sure that that was a chip that I had read. That looks fine. I wonder if I've got some problems with the reader. That's a jotter. I can't see anything wrong with that. Okay, let's have a look. Just try another one. It is possible that I have got some bad chips, but I don't remember having that many bad ones. I know somewhere there was a little bag that I put chips in that I'd marked tested. No, that's a different one altogether. That's a NAND, not an EMC. It's actually always slightly longer. I don't suppose you'll see that much. Yeah, you can see that. Same pattern on the back, but it's just the different format. Let's see what else we got. A slightly different one. And somewhere here, there's yet another NAND. Yeah, this is crazy because I know that I have got some that work. Well, I've got a brand new chip, so we'll try that. The only problem is these are 64 gig, so to try and read it would take about half an hour. So I'm not going to read the thing, but it will show me whether I've got a problem with the reader or with the adapter. So I'll just pop that in there. Well, that seems to fit fine. BGA, yeah, 153 and 169. So I don't know what's going on there. Ah, no, that's found that straight away. I'll go over to it. There you go. It tells you there. It's found the chip. MMC 8-bit, so it's connected to 8 bits. That's data 0 to 7. There's the idea of the chip, whopping great long number. It's a SanDisk, SEM64G size. There you go, 58.24 gigabits. And so there's its serial number. The thing is, there's no point in me trying to read it or do anything like that for the simple reason there's nothing on it. This is a blank chip. But it does show that everything at my end is working. I'm just unsure why we can't read those other chips. Now I know for a fact that the other one's good. The not the one that came out of the Xbox, that one I don't know. But the other one I tried is definitely a good chip. Let's just have a little look and just make sure we haven't lost some off the chip. Now, where's the brand new one? I think it was that one, was it? Let's have a look. Yeah, it's 64 gig here. I'll just put that one back in its packet. Now, actually, not that bad. About 14 quid for a 64 gig chip. What I do is to convert things like little car things that use sat navs and things that wouldn't not sat navs, sorry, media units that go in cars. They come in 16 gig, 32, 64, but there wasn't not enough room on 32 gig ones to put maps on for the sat nav, so we used to upgrade them. But apart from the spurious ball there, which I'm wondering if that's stopping it going right down. But not only that, this one didn't read either. Now let's compare that. See, that's much the same chip. In fact, it's identical virtually. Yeah, that's identical. You can see the pins have been on the buttons, although it looks like they might have just slightly missed there. I'll just try out again just to see. What's the number of this one? This is that one, KLM G2G, yeah, it's just a smaller chip. So we'll have a look at this one. This is the one off the Xbox. Apart from lumps of dead finger in there. The rest of it. Oh god, where did the hair come from? My word, there's my hair dropping out everywhere. Okay, we'll try something else. My word, that is filthy, look at that. Okay, let's just give it a bath. Hang on, we'll drop it in some IPA and give it a swish. How on you? Let's see if we can get the muck out of it. So like I said, everything normally goes arse over the tip when I try and do it live. I was rather hoping to expose what was in the chip, but oh my word, that is so dirty. Better state that. Oh my goodly aunt. I'm going to have to get some of what I call my snood put over my head to stop my hair falling out, I think. Tell it's mine because it's grey. Oh, word, it's done half of it. Where's it all coming from? That isn't once a scratch. Oh, my word. Come on, you. It's like when I'm soldering. If I forget to tie my hair up, you bend forward and you get this horrible stench of burning whiskers and hair, and oh, it's lovely. Well, there's nothing there really that I think would cause a problem other than the fact it's just bloody filthy. I don't really want the guns going into the reader. Let's have another look. I can't really see anything there that's a reason for it not to read it, other than if the chip has it should auto detect whether it's the well, it's now. Look at it, it's all this bleeding hair coming from. I've got it stuck over my microscope. I bet a cat's been in here or something. That can't be all my hair. That's right, that's cat hair. There's a cat been on this bench. Shoot, the little rat bag. Oh yeah. Still not great, but I'm going to have to try and get that out. I can't put that into that reader, that on there. Oh, it's stuck on my toothbrush, that's why. Can't teach me to comb your hair with a toothbrush, won't it? Oh, it's time to get a new one. There we go. Right. Just whip that funny little ball off that shouldn't be there. There is, that's hair on this mat. Okay. No, definitely no shorts on there. I'm just going to oodle that little bit of solder off that corner, although I don't think that's probably going to have anything to do with it. It's only a tiny little bit. That's it. And the chip run away. That's gone. Oh, it's there, but it's flat. That's all, man. Alright, we'll give it one more go. I'm going to have to get the old blower out and give this bench a puff over and see if that's where all this hair's coming from. Right, let's get this thing back in the gizmo. Let's get the microscope out of the way. Move over there for a second. Right. Can't see the spot again. There it is. I will notice that this chip doesn't fit. As well as, oh, I don't know, there's no movement in it at all. I think just that those 64 gig chips are a little bit tighter, but oh, I've done it again. Right, let's try again. You also notice the orange LEDs on the reader weren't coming on. Let's try, oh, they are this time, look. Ah, that's now reading. No, it's not. Is it? Yeah, that's actually reading. It's a 4.9 gigabyte. Ah, okay, let's read it. So rename that xb1 bin. Okay, so we'll read, I'll leave it at the speed it's at. So we're reading in 4 bits, so we've only got 3 data bits, we didn't get all of them. So, but it's good enough to read, possibly. CRC error, okay, so we're going to slow it down a bit. Drop it down to user clock. Read again. USB operation timed out, save as, yeah. Okay, auto. So we've got 392. It's not happy, is it? Timed error, so it's having a read problem. Now we're at 15 meg. Let's come down to 10 meg on the clock. And let's try that, see if it'll read slower. So read question USB timed out. So now there, data error. Right, we're not reading for some reason. Now we've lost the we're not reading the data pins, so let's go to query. Yeah, we've not got data, so we're having problems connecting. There's the trouble. Let me just give this thing a bit of a wiggle. Right, okay, now we've got all data, all 7 or 8 data bus, right, 15. Let's just try a quick read, come on. Yes, come on, don't stop. Yeah, we're reading, okay. Now we're reading, bugger, CRC error. Oh, that's only at 10 meg. My word. Let us drop that down to 1.8 volt. Read again. Yeah, I know it timed out. Carry on. It's reading again. Just drop the. Well, it's auto detecting back to 3.3. And throwing the error up again. So let's turn the socket off for a second and let's drop the clock to take that out for a second. Let's put that at 15 meg and we'll just try that. Read again, query. Right, so we've got all connections and read, overwrite. It looks like the chip's got a problem by the looks of it. Yeah, CRCR again. Hang on a point, where am I saving this to? Oh, it's alright, it's on the G drive, that should be good enough for that. Let us try, oh, I've got 135 meg in there, that idiot. That should have been 15 meg. Okay, let's try that. Yeah, I know it's timed out. So what's the read from 13C0? Okay, I suppose what we could do is try reading 4-bit mode. Let's try that. And then we can always try reading, it's happy to read 8-bit though. And I think to do is to try and read a smaller section. It looks like it's got an issue, either that or it's still connected. It does start to read, but then we get a CRC error, which could be data problems, or it could just be reading problems. It might pay to try yet another port. Oh, it's reading a bit more this time. So we're on 4-bit mode. But it's detected 8-bit. Yeah, reading 4-bit transfer. Okay, well, it could just be that it's designed to run 4-bit transfer, I don't know. We'll see in a minute. It can take a bit of time. 11 minutes 51 seconds. That's 6.64 megabits a second. Alright, well, there we go. Hopefully, it's the first time I tried to read the xb1s NOR, so we'll see if we can get it to read. They can be a bit temperamental, things like this, I must admit. I'll leave that reading over there. I don't really want to put too much of that out on screen. And let's see what else we got. Right. Well, I had a great fault on this board earlier on. I think I did say about that. That's where this chip's from. This was a beep on, beep off. It turned out to be the APU with a short on it, as I said. But what I shall do now is to use the board to try and actually track out some of the key features of the circuits, like the RAM system, which is pretty good, it's clever, and the actual on system, which are the two biggest problems of beep on, beep off. This one is all controlled from the APU on I2C, and then that talks to this and that as on to I2C, depending on what other bits it senses. But yeah, I've now got the socket in to make the reader for the checking the HDMI chips. So I'm going to build a little system so you can pop these in to this little reader here and check them before you use them. Now, although if you look at this one, so it takes the little tiny, you can see that little 40 pin. And all I've got to do is I'm going to connect this up basically so that it sits here. It'll be a special board built up, special heatsink. I mean, you drop the chip in, check it, and also playing around with this booster IC. A few ideas for that for the X to replace it with something different. A few ideas on the blow, but it takes a bit of time. Right, is that still reading? Yep, cool. So this board, I've drawn some up. I'm going to try and do a what you call it for Paul Daniels software. I know how it's done. So I was talking to Paul about it. The biggest problem is you've got to draw it all in to a CAD program, export it as another file, then basically from that you can put all the data into the different modes via the server. But it's actually drawing the darn thing, which is something I'm hopeless at on computer. So I'm not sure how to go about it on board view. That's what I'm trying to think of. I've done a bit of the power supply because I got all the power supply schematics, or most of them. But that's about it. And of course, everybody's got the PS3. What else have I got here? I can tell you while I'm waiting for this. Not a lot. Got loads of DDR2 memory, which I've removed, just cleaning them all up, and then I shall reball them. They're all pretty good. I have got a tester for these as well, similar to what this thing is with the what's it on, similar to this here. But what you've got is all these, and what these are is, in there's a frame that is just the size of the chip, so it sits in there. And what these are all different size frames, and you just swap these over inside that and then drop the appropriate chip in. So that convert most chips to read, mainly memory and EMMC. Then I've got a NAND reader, and a few other readers that we use for doing other things that I'm hoping to adapt for use of. Let's see how we go. What else have we got? Oh yeah, it's got a nice APU with a short on it. That came off pretty good. I've got a heater, I've got a refurb machine that unfortunately it went seriously wrong. The optical alignment packed up. I used to have a camera folded out, and you could line the chip balls up with the board itself, and then it lowered it down. I bought it second hand, it worked for a while, and it's just gone really wrong. Trying to get some parts for it. What I'm having to do at the moment is to use it sort of semi-manually, so I can heat the chip up, and I can lower the sucker onto it and lift it, but I have to do it all by hand. It's electronically motivated, but I have to key it all in from a computer to make it work. The controller has fizzled out, and they just don't make it anymore, so if I can sometimes perhaps sit and convert one. It's not too far away from the similar controller for a mill, which I have got. Use Mac 3 control software for it, and I did wonder whether it could convert that. In fact, you probably could use a driver from a 3D printer, to be honest. It only needs stepper motor drivers, and they're fairly accurate. So what I'm going to try and do, I don't suppose I'm going to find a pinout for this baby anywhere, but I do know from the board what the ground pins are, and I know what the supply pins are because you can follow them back. And what I have found on here, this does have a feed from the RAM feed, the 1.1 volt. I found on the board, I found at least 4 that go to the same point. What I need to do is to see if I can find the pins on here and the ground. It'd be nice just to really say, oh look, that's short circuit. The thing is, I stuck a good 6 amps into it, and it only just showed the slightest glow around where the CPU was. It was very minimal, it really was, and I didn't think that was enough for it to be the CPU. But there you go, it surprised me, it was. So you live and learn. It'd be nice to be able to change them, but there you go. I have got a spare, what do you call it, a south bridge. I haven't cleaned it up yet. I'm going to have to just put some solder on it. I'll probably reball it actually. Otherwise it'll go corrosive. So if anybody needs, that is a good one. Needs one, I've got one. We can negotiate a swap for some, I suppose, a leg or something like that, a couple of fingers. I'm not fussy. What else is happening? I managed to get some 58s, 158s, and I've also managed to lose a lot of 158s so far. I had someone order from last year, which I got told they're not going to be here till next year. And then turns out they got a load this year, which I ordered a load of and got. And then they said, oh, we can supply you some of your other order. And seems to have gone astray, as it looks at the moment. So I'm not best happy about that. But now, never mind. No, it's still reading. It's getting there. It's where are we? Fair way up. So I'll let it read and I'll have a quick peek. Oh right, yeah, something else I was going to tell you guys. These things. The inaugural 10 watt Northern Lights Super Duper Zapper gun. Right, done some tests on it. If you're running it off a standard USB, the USB just cannot keep up the 5 volt with it, and it drops to less than a watt, about 1 and a bit watts. I'm running this on 6 volt, and I'm running it through, it's still through the USB, but what I've got is a little bit of a, hang on, let me just untangle this for you, a bit of a setup so I could show you. Right, as you can see there, what's that, 5.6 volts, something like that. I'll bring you in a bit closer. Yeah. Oh, come on, focus. Come on, baby. Melt it down. There you go. I'm actually running it off a 6 volt source. There we go. From that, if you look at that, that's drawing, oh, come stay in focus. Right, it's drawing over 600 milliamps nearly. 0.6. So 600 mils, 0.6 of an amp. Just wait for that to go out. Yeah, it's still on. Oh, I can turn it off, can't I? So 0.6 of an amp, V times I, will give you watts. So 0.6 times 5.6, won't it? That's exactly 3.3 watts. So this 10 watt thing is 3.3 watts, even on a good supply. My guess is, oh, they're probably saying it's 10 watts as in like they rate LED bulbs, you know, 8 watt bulbs, 80 watt, 3 watt. I've no idea how they got this figure. It's not a 10 watt lamp and it never will be. I've run it up on a power supply and I've taken the current up, gets sort of so close to 5 and 6 watts, and by Christ, it melts. It gets so hot, it's ridiculous. But it does work. I'll say that. That works quite well. I've got another one here, that one. That's got 3 LEDs inside it. And that does outperform it. Although this seems, it sort of got, when you look at the light, if you shine this, say, onto white card, so you get the reflection, this has got a lot of white light in it, a lot of non-UV, whereas this is all UV. And in the dark, this actually makes my printer, it's printed with ultra UV reactive plastic, and it glows in the dark. I don't think I'll be able to show you that, but I think this is now finished dumping, so I'll stick that out the way and I'll go and have a look, see what we got. I'm going to have to try and, what I'll do, I'm going to stick you back just in general. Where can I put you so you've got something to see? I'll just stick you there for a sec while I go and have a look. Right, I'm going to have a look on Drive. G. UFPI. What do we want? UFPI, where is it saved it? Oh, in the wrong folder. Back, UFPI back, there it is, bin. Okay, well, let's just pop this into hex edit and have a look. Let's see if there's any ASCII details that we can read. Probably fine that this is encrypted, I would think. 4 gig. Oh, hang on, Hexedit ain't gonna like 4 gig, is it? I'll try it. It normally falls over much over a gig. Right, Hexedit. I'm just going to drag the file in. Sorry I can't. Oh, can I share? Of course I can share this, can't I? I could. I think I'd better not for a minute. Hang on. I don't know what's on in the file. Okay. Right. It looks to be encrypted. What's this? Yeah. Yeah, I would say this is definitely encrypted. I don't know if they've just used a hash on it or definitely. Yeah. Let's go back up a bit. Hang on, I'm in an empty area. It certainly looks encrypted. Most bin files or hex, you can sort of read the header. It sort of indicates the type of file it is, but this is definitely looks to be. If I've used an MD5 or what I've used on here, I should have to have a look. Yeah, well, it's encrypted, so you can't actually see a lot, unfortunately. But what I can do if I go to, what do we want? Hexedit. Like I say, you can't actually really read a lot, but it was interesting. Managed to somehow delete one of the windows I had open, so let's try going back to that for a second. Right, let me just shut this reader down for the moment. So we'll close that, store that, so shut off power, yes. We'll close that for a moment. Yeah, thank you. Goodbye. And then we'll go back to the bench. And just a sec. I've got to go over to the buttons. Alright. Okay, we're back on the bench. I should be coming back to the bench. See if we can go back out a little bit. Right, I'm just going to unplug that. And that. And let's just take that chip out of there. So I think the reason that wouldn't read was basically it was could have been a bit of muck in the base of that. I don't know. That seems okay. I'll just pop that back in its box. But yeah, it's an interesting subject. Reading and writing data and chips and programming them is something I do a fair bit, as I think some of you know. I do a lot of software manipulation, for want of a better word. Right, now see what we got here, all these memories. Now that was the what's it one, wasn't it? Yeah, I'll stick that in there on its own so I know where that is. Okay, so that can go back with that. These can go back in the drawer. I can't remember where I found them now, so we'll stick them in there. That'll do. Okay, right, have a quick tidy up. See what else we got here. A few other things we got working on at the moment. I've got loads of Xboxes coming, they're behind me at the minute, but I don't know as I really want to start on one at the moment. Work on a little device to help diagnose strange faults with HDMI. Right, several versions of it. One of them's using this little board. What it will do is it will tell you the status of what's coming out the board, be it whether the hot plug detect. I should make it's going to have a little bit of circuitry on it. It's going to have another little board that plugs onto it, which will generate the hot plug detect and the I2C. So it'll tell you whether it's working. And the other one, which there it is, they only sent me one of them, so I had to order a load more, is this one. Now this will go in line, that'll plug in the back of the Xbox or whatever, and then you can plug your TV in the other end. And what I'm going to do is have a little bit of a play. When you jumper the booster on the 1X, if the TV unit is quite modern, most of the time they'll work because they use 3.3 volt, I believe, on the I2C. A lot of the older ones are still 5 volt, and they're the ones where you can get the possibility of it won't switch to 4K. But I'm waiting for some bits to turn up, which are on back order, unfortunately, but may be a substitute, but in a different way. They're certainly not physically the same, but electrically they're very similar. It just means they may have to go on to a subboard. But that's another story. What we got here? Oh, this is just where I've been cleaning up SSDs, DDR3s. Yeah, DDR3s. Just cleaning them up and storing them. Right, well, I think that's probably all I can really do at the moment. Although I have got 13 Xbox controllers here to look at. I managed to got them off eBay. I would say it was dirt cheap, but they are in good condition. 3 faults, which is quite nice. I've got a bid on another lot of 13. Whether I'll get them or not, I don't know, but we'll see. Alright guys, I'm going to leave it there. It's hope it's been of some interest. I know I'm not showing repairs at the minute, but as soon as I sort this lot out behind me, we will do some live rather than recording. Okay, thanks for listening and have a good night.